Welcome to Chapter 7 Ionic Equilibria Titration. Now let's proceed to sketch and interpret the variation of pH against the titral value for titrations between strong acid, strong base, strong acid, weak base, and weak acid, strong base. Okay, so for this section, we will focus on strong acid and strong base. When we sketch the titration curve, there are a few things that we need to take note. Okay, so before titration, meaning that there's no titrant is added to the analyte. Okay, so this is the pH of the analyte. Okay, for example, when we look at this titration curve, we know that in the analyte is a base because the pH is more than 7. Okay, so this is 0 volume of HCl added, 0 volume of acid is added. Okay, now next one is before equivalence point, pH is, okay, so this one will refer to the, later we'll learn about half equivalence point. Okay, now the third point will be at equivalence point. Okay, pH is, okay, now it may not always be 7 for equivalence point. It depends on whether is it strong acid plus strong base. If strong acid plus strong base, we will get pH equals to 7. If we have strong acid plus weak base, we will get less than 7. If we have weak acid and strong base, we will have basic salt. Okay, so it depends on the strength of the acid and the strength of the base. Okay, however, you must label 7. Okay, now next one, the last one will be after equivalence point, means you keep on adding the titrant until finish, and then you will know what is the pH. Okay, so now we continue with this. Okay, so for strong acid and strong base, okay, so just now I've said it, the second point will be the half equivalence point. Okay, so what is the meaning of half equivalence point? It is the concentration of an added base equal to half of the original concentration of the acid. So the half equivalence point is also known as midpoint of the titration. Okay, before we proceed further, how do we get the equivalence point? We use MA, BA per MB, VB equals to A per B for titration. So we will know what is the volume at equivalence or what is the concentration at equivalence point because they will completely react. Now let's look at one example, strong acid, strong base. Okay, now we have sodium hydroxide and hydrochloric acid. And if we look at the information given, HCl is the analyte because we know the concentration and also the volume. Okay, so it is in the conical flask. So our titrant will be NaOH. Okay, so we have 4 points that we need to draw for strong acid and strong base before titration. Okay, so if we look at this, before titration, there is only acid. So we expect that the pH in the conical flask or the analyte should be less than 7. Okay, how about at equivalence point? Okay, at equivalence point, okay, let's go back. Half equivalence point is the concentration of an added base equal to half of the original concentration of the acid. Okay, so later this one I will show you how to use calculation, but because it is not neutralized yet, it is still less than 7. Okay, only at equivalence point, acid and base completely react. So we will get neutral salts because it is from strong base and strong acid. Okay, after equivalence point. After equivalence point, we will have neutral salts and excess base. Therefore, we expect the pH would be more than 7. Okay, now let's look at the calculation part. Okay, so before titration, we only have strong acid. Okay, so to calculate the pH, so we use negative log H plus concentration. So we will get 1. This means that when there is no NaOH added. Okay, half equivalence point. Okay, so half equivalence point, we can see that here. Okay, it's given 0.1 molar and then we have 25 ml in conical flask. So if we change it to mole, we will get 0.025 mole. And stoichiometry coefficient wise, 1 mole sodium hydroxide reacts with 1 mole hydrochloric acid. Okay, so if we want it to make it to half, okay, if we want to make it into half, the concentration of base, half of the acid, that means it is also the same number of mole. Okay, so what we can see is NaOH completely react with HCl, whereas HCl is in excess. Okay, so we just do the calculation. Then we again find out how much is remain. Then we can find the pH for half equivalence point. Okay, now we proceed with at equivalence point when acid and base completely react. So the concentration of hydrogen ion is equals to the concentration of hydroxide ion. So pH equals to 7. It is a neutral salt. Okay, after equivalence point, the pH will be more than 7. Okay, or we know that POH equals to negative log 0.1. Okay, this one is from OH minus concentration. Okay, so then we will get how much? And then we use pH equals to 14 minus POH. Okay, for example, maybe you might not understand about the half equivalence point. Okay, so I shall put it here. I rewrite again NaOH plus HCl. Okay, now initially we know that acid has 0.025 mole. Okay, and then what happened is we know that half midpoint or half equivalence point, it will reduce to half, 0.0215. Okay, so same thing for sodium hydroxide. Okay, sodium hydroxide will be 0.0125 mole as well because they have the same concentration. Okay, so we know the volume will be 12.5. Therefore, at final, we will get 0.00125 mole of hydrochloric acid. Okay, so from HCl remain, remember HCl completely dissolved, we'll get H plus and Cl minus. So the H plus will represent the pH. Okay, now next one, let's look at this. Okay, now just now we have calculated at 12.50 when sodium hydroxide is added. Okay, 12.5 ml of sodium hydroxide is added. The half equivalence point just now calculated was 1.48. Okay, so roughly about here it is 1.48. Okay, then the second one must highlight at equivalence point, must write down the word equivalence point equals to 7. Okay, and then this is the last point where the pH is greater than 7. Okay, and then don't forget about the steep. The steep is pH 4 to 10 for strong acid and strong base. Okay, what does it mean by the steep? Okay, you can see this part. Okay, where it is very steep. Okay, let me highlight it. Okay, where this part, it is very steep. Okay, so for 4 to 10 is only for strong acid and strong base. Okay, so remember to calculate this one is MAVA over MBVB equals to A per B in order to get the volume of equivalence point. If we want to get half equivalence point, okay, so remember the base is half of the acid. Okay, depends on which one are we starting with. Okay, now let's look at the meaning. Point 1, okay, when there's no sodium hydroxide is added, so the pH is very low because it only has H plus coming from HCl. Okay, then point 2 is the equivalence point. Okay, this is where acid completely neutralize or react with sodium hydroxide or base. Thus, the number of moles of sodium hydroxide and moles of hydrochloric acid added is equal. So the solution only has neutral salt. Okay, so pH is 7. So after that, when we continue to add base, the pH is more than 7 because it becomes basic. HCl has been completely neutralized at this time. So the excess is only OH minus ion, which comes from NaOH. Okay, so remember for strong acid and strong base, there are 4 points. That is before, okay, before acid or base is added. Another one, half equivalence point. Another one is the equivalence point must be 7, okay, for neutral salts. And then the last point will be where either excess acid or excess base. And the steep must be from 4 to 10 for strong acid and strong base. And remember, you must know what is inside the conical flask or what is the analyte, because the pH when no titrant is added depends on what is in the conical flask. Okay, so that's all for titration curve for strong acid and strong base.